to YouTube afterwards. So you guys are more than welcome to go and check it out afterwards again. My name is Steve. I'm a project engineer at Adroit Technologies. And today I'm going to discuss with you the energy saving that you can accomplish with a Mitsubishi VFD and show you monitoring it with the Adroit SCADA. Okay, so as I just mentioned, I'm going to show you guys the Mitsubishi VFD with energy saving capabilities, and then I'll show you how it works by monitoring it with the Adroit SCADA. So, just a quick run through the Mitsubishi electric VFD range. We have quite a big variety of these VFDs to cover almost every last possible application that you can think of. If we start at the very small ones, that will be our D700 range, which is 0.4 to 7.5 kilowatt on the 380 volt units and 0.1 to 2.2 kilowatt on the 220 single phase unit. Then we move over to the CS80 range, which has 0.4 kilowatt to 15 kilowatt on the 380 volt range and 0.4 to 2.2 kilowatt on the 220 volt input range. Then we have the new E800 VFDs, which will cover from a 0.1 kilowatt to a 30 kilowatt on the 380 volt side. And again, the same for the 220 volt side, a 0.1 to 2.2 kilowatt. Then we move over to our FR-E800s, which is the Rolls Royce of our VFDs. There we can cover from a 0.4 kilowatt up to 1,500 kilowatt. Our F800 VFD, which is very popular on the energy saving VFDs, where we can cover from 0.75 kilowatt up to 650 kilowatt. And then we also have our medium voltage and high voltage range. Okay, so when we look at energy saving, we can use a VFD to control the speed of a motor and to control how it operates. With a survey that was done by a couple of electrical engineers, they have established that the most absorbed energy of electrical motors falls in the following categories. Pumps will absorb 31% of your electrical bill. Fans up to 23% of your electrical bill. Air compressors 8%. Other compressors 14%. Conveyors 8%. And other applications up to 16%. It can be seen that the biggest consumer of electrical energy are pumps and fan applications. However, these will offer the largest energy saving possibilities as well. Traditionally, when you buy a pump or a fan, the engineers will use the next higher performance curve for your application to make sure that a pump will always meet the requirements that you have specified for your application. Most of the times these applications are run on direct online or star delta types. Now, using a direct online or a star delta controller, your motor starts up, goes to 50 Hertz, continuously run at 50 Hertz. And if you need to control the airflow or the water flow, you're going to install a valve to control the water, or you can install dampers to control the airflow. A classic flow adjustment is you'll have a volume reduction bypass, which is shown in the top right corner, running at 100% motor speed, or just a normal valve also running at 100% motor speed. When you install a VFD, you won't have any dampers or valves required, as you can use the VFD to control the flow required. And I've made a nice picture to illustrate the application. So we have our liquid or our air coming in. With the inverter, we can control the motor speed. We can take a sensor to measure whether we want to work according to pressure or to flow, and we set up a set point in the VFD to always keep at your required pressure or your required flow. So can a VFD save energy? Absolutely. If we had a 50 kilowatt application but only absorb 25 kilowatt at a full load, the difference is wasted electricity. Now, in a lot of applications, you only need to reduce the speed up to or by 5 Hertz to get up to a 20% energy saving. For example, when a 15 kilowatt motor is operated at 60% air volume and the power charge is 50 cents per kilowatt hour used, the power change can be the following. Using a damper controller, for instance, a valve or a damper for damping airflow. And I've done the following calculation where if you run that motor with your damper controller for a full year, the electrical bill will be 95,000 Rand. Using a VFD for the same amount of hours and same amount of airflow, where you control the speed instead of using a damper, your electricity bill will come down to 19,710, which gives you approximately saving over a year of 39,420 rands. So that is the basic principle of the energy saving. We have two energy saving modes in our VFDs. One is called the energy saving mode, and that one covers the following principle. After the output frequency has become constant, which means acceleration or deceleration is complete, the output voltage is reduced gradually and operation is performed with the output power being minimum. When the output current begins to increase due to the increase of the load torque, the output voltage is increased up to the normal variable frequency pattern to generate the torque required to maintain the speed. With this setting, you can save additional 10% on your electric bill from the previous calculations. If we go to our optimum setting, which is optimum excitation control, This combines maximum drive efficiency with minimum power consumption. The OEC control excitation. Sorry, let me just. The OEC control excitation to make the motor loss minimum, focusing on the improvement of motor efficiency rather than torque control. And this can give you additional 12% energy saving compared to the standard energy saving of 10%, or just by reducing the hertz by 5%. Now, I just quickly want to pull up my SCADA here. So basically, what I've done here is, sorry, just admit a guest here. So basically, what I've done here, I'm using our Adroit SCADA, connecting to a VFD over Modbus TCP communication. So there's no PLC in between. I'm communicating directly with the drive. I've designed a faceplate where I can stop and start the drive and also monitor my hertz, my amps, the kilowatt, the motor speed, my energy saving. I'm also monitoring the DC voltage and the output voltage, which I want to show you guys that changes when I enable the energy saving. So if I start the motor, it's going to ramp up to 50 Hertz. And as you can see in my graph or my trend, the motor started up to 50 Hertz, which gives me 1,500 RPM. If I look at my amps, currently I'm drawing 1.31 amps, and that I can also see on my trend. I'm using a 0.4 kilowatt motor, and at the moment, due to the motor being free spinning, I'm using 0.08 kilowatt, which is shown there. My DC voltage will stay constant because I have a standard supply to it. And my energy saving at the moment is 0.33 kilowatt. Now, at the moment, I'm running the standard operation. No special parameters has been changed. So I'm getting a 230 volt output to the motor. If we reduce our frequency to the motor, it's going to start to slow down. I'm starting to draw less current. So that's where the reducing it by 5 Hertz starts taking effect. But it's not a significant amount. Over time, it becomes quite a big amount, but over a short period, we're not really going to see a big difference. If I now stop the motor, let's first ramp it up back to 50 Hertz. And we can see our voltage output at 230 volt. We're going to stop it. So once I've stopped, my energy saving function to enable it becomes available, as there's certain parameters you can't change on the drive while it's running. And now I'm going to start it forward again. Now, with the previous setting, I believe most of you could hear the motor running in the background. Now the motor is running a lot quieter. As you can see, I'm back running at 50 Hertz on my graph, and on my faceplate I get the feedback from the drive for 50 Hertz. But from previously, where I'm only drawing 0.49 amps now with the energy saving enabled. If we go to our trend, we can see quite a massive drop in the amount of amps we are pulling with the energy saving enabled. And also, if you notice on the faceplate, I'm only putting 114 volts out to the motor, but still running at 50 Hertz. And if I go and reduce that to 45 Hertz, I've gained another 0.02 amps on the same operation. And I can show you the speed. There we were on 50 Hertz, we went down to 45 Hertz. We enabled the energy saving back on 50 Hertz. I've went down to 45 Hertz. But we can see quite a big difference on our amps being consumed and also our kilowatts being consumed. And that's running the same motor, just enabling one setting on the VFD. And that basically covers the energy saving with the Mitsubishi VFDs. On the next slide, all my contact details will be available. If any of you have questions regarding this, please feel free to contact me, email me. We're more than happy to assist you with perimeter setups to get the maximum energy saving using our Mitsubishi VFDs. If you guys have any questions that you want to ask now, you're more than welcome to unmute yourself. I'll assist with any questions that we can answer directly now. If you want to see more of the operation, I'm here for you guys to help you with this. Yes, Bradley.
Steve, just check the questions in the comment section.
Just open my comments. Okay, Tabu, the SCADA setup itself is quite a bit complicated. We don't have it's not a pre-made function that you just add to the SCADA. Every single button and indication that you see here is made for this application, but I'm sure we can help you guys with that to accomplish having the same for your site. Sham. So basically, if I use a VFD, I don't need to design with PFC. I'm not 100% sure about PFC. Sorry, Sham, can you just give me a little bit more information on what you mean there?
He means power factor correction.
Okay. Power factor correction. Yes. Using our VFDs, we have a built-in active front end. So you will have a huge reduction in harmonics. But we also have additional active front end that you can install to even furthermore reduce harmonics if you still have that problem. But please note that the drive will only, the active front end will only monitor or filter out the harmonics generated by the drive, not by any other external equipment. Does that satisfy the question? Okay, how does the 5 Hz setting impact the long-term operation of the motor? Absolutely nothing. Your motor might even last longer. The only thing that you need to always keep in mind that you can run a factory motor at 25 Hz for the next 10 years. The motor won't burn out. But should you have an application where you need to run the motor between 0 Hz to 25 Hz, you're definitely going to require additional cooling on the motor. So always keep that in mind. Never run the motor below 25 Hz if you don't have force cooling installed on the motor. But yeah, the 5% setting, the long term, there's no impact on the motor. Installing a VFD onto the motor will prolong the life of the motor. Jan, you have a question. Jan, you can unmute yourself and ask.
Hello, sir.
Yes, how are you?
Yeah, but I don't know what is happening. It shows that I'm not in the webinar. I'm out. I don't know how. Even I was trying to send some message because it shows I'm out. I'm not with you, but I can hear everything. I don't know why.
Okay, can you see my screen at the moment?
Yeah, I see. It shows the SCADA thing. It's a SCADA thing now.
Okay. Yeah, sorry. We had a problem with YouTube, so we had to move over to the Teams meeting.
Okay.
Because the software that we use to stream to YouTube is not connecting to YouTube, so we had to use Teams as alternative to do the presentation.
Yeah, I've moved, but even the list of the participants, I'm not there. But during the start of the session, I was listening you. Again, there's another question there. I don't know how we have answered it. Someone asked, what is the impact of running a drive with 5 Hz? What is the negative impact? Maybe running it continuously, like 24/7, something like that.
Okay, so it's not running at 5 Hz. So let's say you have a VFD installed on a motor for a pump or a fan application. If you reduce from 50 Hz to 45 Hz, so you have a reduction of 5 Hz, you're not having any impact. You're going to use less electricity. Use 99% of the time you're still going to have the same output of water flow or airflow, but using less electricity.
Okay.
And then if you are using a Mitsubishi VFD, we have a built-in energy saving function, which when you activate that for a pump or fan application, you can get up to additional 12% energy saving.
Yeah. Yeah. Adding on to that, we have 2 big fans, 1.1 megawatts motors running with big VFDs. Sometimes we run them at 35 hertz without full frequency. Now
Yes.
the current drone by that full load motor, it will be reduced, even the kilowatts. Now the power consumption, it will be less when you pay the bills.
Yes.
Yeah.
No, absolutely.
Yeah, but yeah, I'm a bit concerned because I'm not there in the participants. I don't know why, because I liked the course a lot.
Well, we are going to upload the video to YouTube afterwards, so you can go and rewatch it.
Okay.
Bradley, you have a question?
Yeah, sorry, just trying to unmute myself here. Yeah, just so that everyone's aware, Jan, your camera is on. If you could just maybe turn it off. But so this will be available. Sam will obviously probably send it out to everyone that's participated. We have also recently just I don't want to say released a new technology, but we've built a 2G modem with one of our partners. So in the farms and all these areas where they've got their pivots and their pumps, obviously they want to use our Mitsubishi VSDs because they get the savings, the energy savings. But we've struggled with connectivity or connection to it, so that's for remote monitoring and setting and all that. So we have now got a 2G modem with a minor monthly fee, or let's rather not say monthly fee. It's a 2-year contract. And if you guys are looking for any type of remote access with an app on your phone where you can start, stop, check alarms, errors, so you can actually change parameters remotely. It's a really amazing product. Then just please chat with Sam or the marketing guys or Steve, whoever your sales representative is.
Thanks, Bradley. Then
I think we'll do a webinar on it in the near future, hey, Brad?
Definitely, Dave.
Cool.
Yeah.
Okay, Dave, to answer your question, no, it's not a maps or Adroit object yet. We can change it so it becomes an object that we can send out to customers to use.
Yeah, I mean, you can make a wizard. It's not an issue at all. You can make a wizard, make an object out of it, and it builds the tags and all that stuff. So,
yeah,
but it looks good. Thank you, Steve.
Thanks, Dave. Pierre have asked, can you get the slides for the webinar? Pierre, I'm quite sure we can send you the slides. If you can email me your email address, I'm gonna let me just put my email up so you guys have it. Where's my so there's our contact details, that's our landline, and then there's also my email address. You're more than welcome to email me, then I'll send it to you. The video will also be uploaded to YouTube, so you will be able to go and rewatch it. Then Sham has asked, if you're using a VFD on a pump, must you still use a VSD, or does the VFD function as both? Sham, a VFD and a VSD is exactly the same thing. So it's a variable speed drive or a variable frequency drive. There's no difference between the two. It's just different naming conventions. Anyone else have any questions they want to bring up now? I'm gladly to answer them. Otherwise, you are welcome to email me and I'll answer any questions that you require. For the people that has joined late, we'll definitely upload the video to YouTube so you can go and view it again. Once again, we apologize for the issues with YouTube. That was unfortunately out of our hands, but I'll discuss with marketing on how we're going to handle this forward. Anything else from anyone? Okay, someone has their hand up. Let me just quickly have a look. Jan.
Hello, sir.
Yes, Jan, how are you?
Fine. You don't recruit people from different countries to market your products.
That you will have to speak to one of our sales guys or speak to Samantha. She's our marketing manager.
Okay. But now, for another information, maybe I'm not in line. How do you compare your drives with some Siemens brand and Powerflex, Allen Bradley, the durability, the conditions, maybe in mines, something like that, or underground mines or coal mines?
Okay, Mitsubishi is also one of the top brands in the world, so we are definitely competitive with all other brands on the market.
Okay.
We produce the same quality products.
All right.
Bradley?
Steve, sorry, man. I just want to answer that question. So we have done a lot of installations with our Mitsubishi VSDs against competitor brands. And we've actually been really successful on installations. We've got another project where myself and Steve are flying to East London next week just to install a demo VSD and obviously show the energy savings. So we've had customers that have got global standards with other competitor brand VSDs that have now standardized on our Mitsubishi VSDs for all pump, fan, and compressor applications for their plants. And the only reason they were able to do that was because we had proved the additional saving over the competitor brand VSDs. And I'm not talking just Chinese brands and the cheaper brands. We've had success against almost every drive that we've been put up against in the market. If you guys are looking for opportunities to maybe save energy on pumps and fans, our marketing team will be releasing a VSD special brochure that we've been working on from, I don't know what kilowatts it starts from, but it goes all the way up to 180 kilowatts. It's the best pricing we've ever had on our drives. And if there's an opportunity for us to maybe install a demo unit, prove the energy, and then kind of come up with some sort of agreements, I don't know, maybe a deposit with the rest later, then yeah, please let us know. Thanks, Steve.
Thanks, Bradley.
Thanks.
No problem. Any other questions that we can answer now or assist with now? Okay, then I'm going to thank everyone. Thank you for joining in. I really do apologize again for the problems we've had earlier, and we'll definitely look at how we're going to handle this forward to not have the same issues again. I'm going to thank everyone for joining. Have a good week further. Have a good day further. Stay safe, and hope to see everyone on the next either webinar or Teams meeting. How we're going to move forward with it. But thanks a lot for joining.
Barry. Oh, nice.